Hi, welcome to my channel. Stepped surfaces in 3D prints. How to get rid of them without drastically increasing print time. In this video I will cover a new feature in the Slic3r Prusa Edition that will allow you to tackle this problem in an interesting way. This also works for 3D printers that are not made by Prusa. I will have a go at it with my Flashforge Dreamer. The video will cover installation of the software, setting the variable layer height in Slic3r, and some sample prints. So let's have a look. In 3D printed models, vertical surfaces look fine for most purposes, even at coarser layer heights of 200 or 300 microns. However, slanted surfaces show a stepped pattern, which becomes more or less pronounced depending on the angle of the surface. The worst looking areas of a 3D printed part are typically where the surface is close to horizontal. If you want to print a part where you consider this to be an issue, and don't want to resort to post-processing, there's usually only one option: print the entire part in a higher resolution. This, however, dramatically increases print time to the point where even small parts can take several hours to print. The Prusa Slic3r variable layer height function brings the best of both worlds: reduction of visual steps in critical locations and only a limited penalty in print time. First, we will have to install the Slic3r Prusa Edition. It can actually be installed on a system that already has the original Slic3r installed. Both programs will still function after the installation and will still have their own settings. The Slic3r Prusa Edition can be downloaded from the Prusa website, link in the description below. During the installation process, select Slic3r for original Prusa Mark II and deselect everything else if you are not using a Prusa printer. Press Next and complete the installation process. The Prusa Slic3r comes preloaded with several specific Prusa printer and filament settings. In order to use your own settings, go to your original Slic3r software and select Export Config Bundle. This will save all of your printer, process and filament settings. Go back to the Prusa Slic3r and import Config Bundle, and this will add all of your settings to the Prusa Slic3r. All of the Prusa Slic3r settings will also remain available, but you can delete them if you want to. Now let's have a look at the variable layer height function. Import and arrange parts on the build area as you would normally in your regular Slic3r software. Let's start with a model of an elephant. This is a popular model on Thingiverse by Lefabshop, link in the description below. The base layer height for this model is set to 200 microns. For the variable layer height function, you can click the new layer editing button in the toolbar. With this function enabled, you can select areas on your model where you would like to have a smaller layer height to create a smooth surface. Hold the left mouse button over the area that you want to edit and press and hold the left button to reduce the layer height. Hold Shift and press the right mouse button to smoothen the transition zone. You can keep editing regions until you're satisfied with the results. A small help window at the bottom right of the viewport shows the various mouse and keyboard combinations that you can use. Press the Slice Now button to generate the G-code. In the preview window, it's possible to verify the output. You can clearly see here that on the edited regions the layer height has been gradually reduced. Next, you can export the G-code. The export process takes quite a while, but from what I understood from the Prusa website is that they're working on optimizing the code, so that should be solved in the near future. The program is now ready to be sent to the printer by using flash print or by copying it directly to an SD card, whichever you prefer. So the model is now printed on the Flashforge Dreamer. Let's have a look at it under a microscope and compare it to a model with a fixed layer height of 200 microns. The grey model is an older one I had laying around and was printed at a fixed 200 micron layer height. The red model is the new part with the same base layer height of 200 microns but locally reduced down to 70 microns. As you can see, the top surface has improved quite a bit on the red model. This can be seen on the back of the elephant as well as on the top of its head. The smaller layers on the red elephant do show some more vibration artifacts, but this is common when printing at smaller layer heights on the Flashforge Dreamer, at least for me it is. The process settings and the quality of the printer become more critical the lower you go in layer height. Overall, however, the quality has been improved, and if you are planning on sanding the model, this is also much easier with the smaller layer height in critical areas. When playing around with this new feature, I also found that it's possible to place two models on the build platform in Slic3r and to use selective layer height on only one of them. In this example, I edited the layer height on only the front Marvin. The Marvin in the back is left at the base layer height of 200 microns. After printing, it's already clearly visible that the top surface of the standard Marvin shows more pronounced layers than the front Marvin. Under the microscope, it again becomes evident that the variable layer height part looks better, but process settings are more critical. There's more stringing and the part cooling seems inadequate for this specific part, which causes some deformation. This is all due to my setup, however. On the Prusa side, there are some examples of a Marvin with a reduced layer height that looks much better. Well, that's it for now. Please check out my website uptimefab.com for the written article and more articles on how to set up your Flashforge Dreamer for Slic3r. If you have any comments or questions, leave them in the comment section below. Thanks for watching.